Last speaker of today is, last but not least, is Daniel Hering from University of Essen in Germany, not so far from the Dutch border. Daniel has also been a very active member of Eurolympics. We very much enjoyed his ability to really shed light on very complex problems when everybody gave up in understanding what we were talking about. And so I appreciate you are here, and we are going to continue on streams and also very much on stream restoration, because that is where Daniel has done a lot of work in Germany and abroad. Daniel, please.
Thank you very much, Jos. Good afternoon. If we observe the development of freshwater sciences over time, it's obvious that it undergoes cyclic changes. Topics like biomanipulation or hydromorphology have been the focus at certain times before their importance decreased again. Today, climate change is really in the focus in freshwater sciences. It's also reflected by a strong rise in the number of publications, so I do not really agree to your initial statement that there are only few publications. And you see that there is still no saturation. As a result of most of these publications, also of the talks you have heard today, there is no serious doubt left that climate change will be a main stressor for many freshwater ecosystems in future. At the same time, the main legal instrument for managing our surface waters in Europe in future is the Water Framework Directive, which was published in the year 2000. The text originates mainly from the mid-1990s, so basically from times when we just started to deal with the topic of climate change. Therefore, the term climate change is even not mentioned in the directive. And although it is now tried through secondary legislation and the common implementation strategy of the directive to bridge this gap, this obvious discrepancy between legislation and reality should be reason enough to have a closer look on the linkages between climate change, freshwater sciences, and the Water Framework Directive. Against this background, and being the last speaker of today, I would like to give some oversimplified messages concerning climate change and freshwater ecosystems, somewhat summarizing what the previous speakers have been told you in much more detail. I would like to add some examples on climate change and their potential effects on aquatic biodiversity. And finally, I would like to add some ideas about how climate change could be integrated into ecological assessment and what it will mean for the river basin management plans, which have been drafted now with so much effort. So, starting very simple, you all remember that climate change has huge impacts in Central Europe in future, at least according to the projections of the IPCC. However, it's relatively minor compared to Northern and Southern Europe. We expect a slightly higher air temperature all year, higher precipitation in winter, lower precipitation in summer, though not as strongly as in Southern and Northern Europe. But if you had a closer look, as Pete has shown you earlier, even for the Netherlands, in certain seasons, a precipitation decrease or increase of up to 20% is going to be expected. We have heard a lot about lakes today, and summarizing this from a very simple perspective of a river's person, starting with a mesotrophic lake dominated by macrophytes, we have mainly a kind of additional eutrophication effects, more or less following the scheme. We have higher water temperatures, we have a longer stagnation phase in summer. This promotes basically planktivorous fish, which have a kind of top-down effect on the zooplankton. At the same time, we have enhanced productivity over the year by this longer stagnation and productivity phase in summer. Both variables affect the production of phytoplankton, and it has basically also a negative effect on the macrophytes. So basically, we have a shift from a mesotrophic lake dominated by macrophytes to a plankton-dominated eutrophic lake. I just repeat this because I want to compare it to rivers in the next slides. Rivers are, well, a little bit more complex, and the effects might be more subtle, also as a result of these multiple stressors which already affect rivers, which range from hydrology changes, morphology changes, to organic pollution and eutrophication. To judge the additional effects of temperature changes, we have, many years ago, monitored permanently the temperature of 20 more or less near natural streams, 10 small streams and 10 medium-sized streams in the mountains of western Germany. Here it is given the temperature, daily temperature mean over a 12-month period starting in summer until the next summer. And not surprisingly, the temperature of the larger rivers is in summer, of course, a few degrees higher than of the small rivers. But also within this medium-sized rivers or within the small streams, there are quite some differences in summer temperature extremes. We should keep this in mind. We are returning to this later on. This effect is even more obvious if we plot the temperature distribution for a 2-month period in summer. For example, this stream, a small stream, is cooler than 12 degrees Celsius for more than 80% of the time in this period. Why within this stream, which is at the same altitude in the same region, has the same hydrological character, it is cooler than 12 degrees Celsius only for about 40% of the series. So there are distinct differences, and this all is reflected in community composition, of course. If we order the site from the coldest to the warmest according to the summer temperatures and plot against this the abundance of certain invertebrate species, we have a very distinct pattern. Of course, this is correlated to all types of other variables, but in multivariate analysis, with a lot of these variables, the summer temperatures were always among the best explaining for the community composition. To summarize this very simply, again, in such a scheme, we start with a near-natural, cool mountain brook. We expect higher water temperatures, seasonally also a lower and in some cases also a higher discharge, which results in changes in current velocities. All this together, this might lead to a loss of species and also a loss of functions which are typical for upstream zones, which are replaced by species or functions, well, more typical for downstream regions. So we have an effect which we often refer to as pothermalization, so a small stream changes the character more or less to the character of a medium-sized or larger river. So there are several stressors which are added by climate change to rivers. For example, hydrology, water shortage, or also floods, as Pete has shown you earlier. We have this pothermalization effect, which is also somewhat related to eutrophication. Of course, we have a direct impact through hydrology or through temperature. This all affects community composition, more general terms, biodiversity, and I would like to show you 2 examples on a very large scale. And I would like to start with some very simple hypothesis showing that the impact of climate change is very different between species. Endemic species which are living only in a very short, very small region are much more endangered by climate change, of course, than widely distributed species which live already today under very different climate conditions. Species inhabiting larger, warmer rivers might be capable, given a global warming, to move to the cooler upstream regions. It's not possible, of course, for species inhabiting springs. Cold thermic species are especially endangered, and more general species living in very specialized conditions, so having very small niches, might be most affected by a drastic change of the climate. So we are particularly interested in endemic species, species inhabiting spring, cold endothermic species, and those with small niches. I would like to give you some examples for a certain insect group, Trichoptera, which are living in both rivers and lakes, and we have about 1,200 species north of Europe. We have reviewed the literature about Trichoptera quite extensively in Europe and have extracted from this a lot of information about species traits, ecological characteristics, and distribution patterns. Evaluating this first under this first question, which species are endemic, we see that the number and percentage of endemic species changed drastically from north to south. There are almost no endemic species in many of the northern European ecoregions, but more than 140 endemic species alone in Spain. Similarly, the share of taxa which are preferring springs, so species which cannot further move upstream, given global warming. They are also mainly distributed in the high mountain regions and Mediterranean ecoregions, and not so frequently found in northern Europe. And finally, the cold sternothermic species, you would expect them to be most abundant in northern Europe, but this is not the case. They are especially restricted to the high mountain areas. Summarizing this all, the endemic taxa, spring-preferring taxa, the cold sternothermic taxa, and those with very small knives. We have a share of more than 50% of this potentially endangered species in Spain, also very high shares in Italy and on the Balkan, and the high mountain areas, Pyrenees, Alps, and the Carpathians. Moving on to a more specific example on the side grain, which is not from our group, but from a French group, which was also involved in Euro-Olympics and which was recently published. And the colleagues have investigated the fish fauna of more than 600 more or less near natural streams. They have applied climate scenarios to model the water temperatures under present and future conditions. And given the fact that the temperature preferences of many species are well known, it is possible then to model the future distribution of these fish species under different climate scenarios. First, having a look on the change of species numbers under the estimations of these models. First, the present number of species, and both under a more conservative and a more progressive climate scenario, the number of species is expected to increase in most sites. Might be surprising in first instance, but if you have a closer look, this is mainly related to the fact that many of the cyprinid species, or the bad guys basically in terms of Eric Jeppensen, are expected to move in because they are preferring warmer temperatures. Species such as the barbel, for example, which is expected to increase in abundance given the large blue spots on the upper map, or even to colonize new sites, the blue spots on the lower map. In contrast, cold sternothermic species like the trout are expected to decrease in abundance or to even disappear in many, many sites. Of course, all of these models have, well, a high uncertainty because the climate projections are relatively uncertain and many other components of these models are also very uncertain. But I think the take-home message is that there is a lot of evidence that climate change will have a huge impact on freshwater biota in future. Against this background, it is important to consider the future climate change effects also in many practical parts of freshwater science, for example, in ecological assessment. Again, Water Framework Directive came into force at a time when we not dealt too much with climate change effects on freshwater ecosystems. So it might not be considered in the Water Framework Directive adequately. What the Water Framework Directive does is mainly comparing the present situation with ideal reference. And there are now some, well, attempts to bridge this gap between this legislation, which is more focused on the traditional stressors like eutrophication, and the future climate change effects. There are two more general papers, policy papers, dealing in a very general way with climate change and water resources. As a result of this, basically a strategic steering group, climate change and water, was established under the Common Implementation Strategy for the Water Framework Directive. And this strategic steering group produced a guidance document how climate change should be considered in the future river basin management plans. For the first management plans, which have already been drafted, there is a kind of qualitative estimation, well, a kind of climate check of the programs of measures expected. This has not always come into force, of course, because basically these river basin management plans are already there. But for the second and third versions of these plans, a qualitative estimation is expected, especially concerning the program of measures, the adaptation measures. Furthermore, this guidance points on the importance of the surveillance monitoring to really monitor the long-term changes which are driven by climate. It expected an intensive monitoring of particularly sensitive aquatic ecosystems and species. It does allow definitely to assign in future water bodies to different types, for example, if the hydrological character is changing. However, the reference conditions for types should, if avoidable, not be changed. All of you know that for the Water Framework Directive, a huge amount of data is sampled, biological indicators, and some supporting physicochemical and hydromorphological parameters. Many of these parameters are more or less specific to certain stressors, for example, acidification or eutrophication. They are then summarized, usually in a very complex way, into a quality class. And from this huge amount of data, basically the needs and also the type of restoration measures can be extracted. From my point of view, this should be amended in future somehow to better concern climate change effects. Some of these metrics will certainly be needed to adapt it if, for example, a large number of sites is being moved to another type. And there might also be the need to add some metrics which are more specifically reacting to the direct effects of climate change. To make it more precise, I would like to give an example for benthic invertebrates, a group which is very often used for monitoring. Usually these monitoring systems or assessment systems follow all more or less the same scheme. From a taxa list of the species occurring in a certain water body, well, a number of metrics or indices is calculated, sometimes only one, sometimes several, which give you information, for example, about the tolerance of the species against organic pollution or if there are specialists for rare and important microhabitats. All these values are then compared to an expected value under reference conditions, which leads to an assessment for each of these metrics. And finally, they are summarized to a quality class. So we could now say, under future conditions, these reference values are not really achievable anymore. But this, according to this new guidance, should not be done. What could be done, of course, is to move some sites into other types, for example, if they change the hydrological character. Or, of course, we could also supplement these existing assessment systems by indices, for example, reflecting the sensitivity of species against temperature increase. There are some of these indices already, which would then, in other words, mean that we in the present assessment systems have some signal about organic pollution, for example, about the impact of hydromorphology on the community, for acidification in some case. And this might be in future supplemented by a module especially dealing with the direct effects of temperature. So, finally, measures. As you all know, the measures to be taken to restore the streams and the lakes are summarized in the river basin management plans. The first plans are mostly there, and there will be updates the next in the year 2015. These new guidance documents specify what is expected from the future versions of the river basin management plans. I already mentioned this, that there is a quantitative estimation of predicted climate change effects on freshwater ecosystem health expected for the second version. Climate change should be no argument for lowering the environmental targets, according to Article 4 of the Water Framework Directive. And in any case, measures which are addressing different stressors, including climate change, should be given priority. So this is pure legislation, very general, not very specific. But what could this mean in practice? Returning to this example, 20 streams, most of them the same size, the same altitude, a comparable hydrology. And we see that the temperature patterns are nevertheless very different. This means climate change on top would certainly further diversify this pattern. It would also probably further diversify the ecological quality and the community composition. Second, this picture might give us some idea why these streams are so different already today in terms of water temperature and community composition. And maybe you can learn something from this concerning future measures which might adapt our rivers to climate change effects. There is a huge number of reviews which parameters affect river water temperature. Of course, there are many natural parameters like groundwater inflow or altitude, but there are also many human-induced parameters. For example, the shading of a sampling site, which affects river water temperature through radiation and through groundwater and soil temperature. But also the shading of the upstream reaches, the shading of the tributaries. A very good explanatory variable is the share of forest in the catchment. And of course, many other human-induced factors like water abstraction, stagnation, sewage, and cooling water. So which of these many factors can now reasonably be addressed with measures in river basin management plans? Share of forest in the catchment, certainly not. Water abstraction, stagnation, sewage, and cooling water, a lot has been done on this already, so there's often not very much potential left. But the shading of the sampling site, of the upstream reaches and of the small tributaries, this is really something where a lot can be done. So my plea is for very simple measures, basically buffer strips and riparian vegetation. So shading of ideally long river reaches, not only thinking about the relatively large Water Framework Directive relevant rivers, but also the small tributaries. We should not forget about this. And you all know that this very simple decade-old measure has a lot of additional benefits. For example, the hydromorphology and also diffuse nitrate input. Summarizing this in the second last slide, rivers in Central Europe, one of the main expected change due to climate change are potabilization effects due to temperature increase. Potabilization effects are already reality due to the absence of riparian vegetation in a large part of our river network. And the measures are there basically very simple buffer strips. More or less similar for lakes, we have heard that there is a huge number of internal measures, but also buffer strips might help here a lot to reduce also the impact of fertilizers. And we have not heard much about Southern Europe. Eric mentioned it somehow in his talk. This is great pictures there from Turkey. The main impact of climate change is there an increase in water shortage, which is already reality due to the excessive irrigation for agriculture. And the only measures which will help there are alternative irrigation techniques. So basically all these measures here concern agriculture. Many of us, I think, are very critical with the Water Framework Directive. It's a very complex legislation, could be much simpler. This natural references as a kind of ideal state is very questionable, and the time schedules basically are pure illusion. But I think even those of us being very critical must confess that, well, the Water Framework Directive is a brave attempt. It's almost a vision. This idea of a good ecological status of the majority of water bodies is extremely ambitious. As scientists, I think we have to make clear that already today this goal will never be achievable without a drastic alteration of the agricultural land use of the riparian zone, just to buffer diffuse inputs and to enable a certain connectivity and also a certain hydromorphological change. This is even much more obvious in times of climate change, so my conclusion is basically protection of freshwater ecosystems in times of climate change will require alterations of agricultural land use, especially of the riparian zones. Thank you for listening.
Thank you very much for this interesting talk about the Water Framework Directive, and also thank you for proving the IPCC wrong about a number of studies of marine and freshwater habitats.
Sorry about this.
But it is true that after 2004 the number increased, and that's probably also because of Ural impacts, right? So I would like to give the floor to questions. We have still time. I know that you all are mostly very involved in the Water Framework Directive, so are there any questions from the audience about that? I think that the issue of trying to involve climate also in that is quite a complicated one, and I think you also touched on, at the very end of your talk, on the difficulty of the whole concept, which is very ambitious and brave, but also how can it actually be implemented and totally according to the original plan, and if you think of legislation, then also according to the laws that will now be enforced. Any questions? Yeah, Martin. What's his main critique on the Water Framework Directive?
Well, if you would like to read a good critic of the Water Framework Directive, I would recommend two articles, one by Brian Moss in Science of Total Environment, and one by P10 and Dufour, recently published in River Research and Applications. Personally, I'm not so critical. I think this Water Framework Directive has its weaknesses, especially the time frame. So the strict time frame, let's say in 2015, we have to reach the good ecological status. If you see all these problems in implementing the measures, especially in the densely populated areas, this is a complete illusion. So we definitely need more time for it. Also, the very complex, prescriptions for ecological assessment, it could have been probably made much more simple, or at least allow more flexibility. Nevertheless, I think it's a very useful tool. We have a kind of possibility there to really implement large-scale measures, but it must be clear, I think, this is very important, that we cannot achieve the aims of the directive with making a very small restoration measure here and a very small restoration measure there, and then just expect that everything will be good afterwards. It will really require large-scale measures along a majority of the river network.
Any comments? Questions? Yeah, Brian.
I can comment. My criticism is not of the Water Framework Directive. It is of the way that the competent authorities have shown no imagination whatever in moving from their previous position and implementing.
That's probably true, if I can just give a comment to your comment. Judging from the German situation, it also contributed a lot of saving, at least a little bit, of these competent authorities. They would not exist anymore, in Germany at least. They would have probably, cut to zero. But now, as there is this legislation with all these obligations, at least at a certain level, they are maintained. And they have much more power than previously. They are not using the power often enough, that's true. But at least they have the power now, and they are still there. And that's already a success.
But if I may comment, one of the important limitations that you indicated yourself is that we actually need quite a drastic change of agricultural land use. And do you think it is at all realistic that this is going to happen? I know that in our country here, already the Ministry of Agriculture has taken a firm standpoint here, and they have published a study calculating how much economical damage would happen if we would really implement the Water Framework Directive according to the letter.
I don't know if it is realistic. I think it has never been as realistic as today, because we now have this possibility with the Water Framework Directive. There are a lot of ways out. So, for example, this designation as a heavily modified water body, which is often used as a kind of excuse to do, less ambitious measures. It's, an own interpretation of the Water Framework Directive, because basically you have to implement measures there as well, as you know very well, probably better than me. So, of course, there are several ways out, and the more densely a country is populated and the more intensively it is used in terms of agriculture, the more difficult it is. Judging from the German situation, I think we have made very good progress in, let's say, the scarcely populated areas, especially in southern and eastern Germany. because their agriculture is moving out anyhow to some degree. But in the part of Germany where I'm from, for example, North Rhine-Westphalia, it's probably the same situation as in the Netherlands. There's done almost everything to protect agriculture.
Okay. Any comments further? Yes, please.
I always have a problem by putting the focus on agriculture as blocking all opportunities for ecological development. There are many opportunities, I think, apart from agriculture, and I think we should also stress on these opportunities because we can make good investments on ecology, and I think what the framework directive is a very good emancipation of ecology. And it's a very productive step, as I see, also together with agriculture.
Yeah, at least I think the ambition is wonderful, and also there is pressure. You can really sense that everywhere, that things have to be done. And I also am not inclined to say that agriculture is the only one to blame. That's not what I want to say, and also I don't want to say that there is no willingness to do things, also in the agricultural sector. They really know that something has to happen, but it will be, quite a task to really get this agreement. We are the polder country, so we have this experience already of dealing with problems together, and I'm sure something will come out, but then it's more for the longer term. That's also something that I agree with Daniel, that maybe not in 2015, but the pressure will remain, and there will be, even after that, probably an incentive to really improve the quality of our environment further.
I agree to you that there are very good examples of cooperation with the Water Framework Directive competent authorities in agriculture. Extremely good examples for certain river basin management plans. Nevertheless, I think we have to make clear that in most of these river systems, agriculture is nowadays the main pressure, because the pressure on land use is really rising. In Germany, there is now 50% of the agricultural land use is used for biofuel production. So this demand is adding to the demand for food production already. And so there are so many contrasting demands for these riparian zones nowadays, and it is a problem which needs to be solved. And this is really a challenge, not necessarily my challenge, it's more your challenge.
Okay.
And in Denmark, the politicians now talk about 2028. They're not talking about 2015 anymore.
Okay.
They are already
looking further in the future.
2 times 6 years more.
Okay. Okay. Any more comments? Well, if not, then thanks again, Daniel. And